Hello. Another type of relationship that we're required to know about is what's called a recursive relationship, or a recursion, or a relationship that relies on recursion. Anyone who does computer science will be familiar with the idea of a recursive call, where we have a particular term in a sequence is based on the previous term in that sequence. A version of this that all of you are likely to be passingly familiar with is the Fibonacci sequence, where a term is equal to the last two terms added together. So a particular term is directly based on the previous terms. Lots of relationships can be written in this way, and it's important that we're able to recognize and deal with these when they come up. The questions do not tend to be terribly advanced in these because they're a little bit outside of the rest of the way that we write patterns. But we're going to put them into practice here. One thing to highlight to you at the outset is an annoying convention. They use letters. Usually they will only ask you for terms in a recursive sequence, but they will use either T, capital G, or capital S for the terms in a recursive sequence. Now this is particularly irritating for S of n, because S of n has a given meaning for the rest of patterns. So be very careful when you're reading questions, particularly if you recognize that you've got a recursive relationship, like we're going to talk about in just a second. S of n, if it tells you in the English of the question that S of n is a term, you have to treat it like a term. So even though we know that S of n will usually mean a sum or a series of terms, if we're told in the English of the question that it is the nth term of a sequence, then we have to forget about that and deal with it as a term instead of what we would usually mean by S of n. This is not a particularly reasonable thing for examiners to do, but they have done it and they are allowed to do it. So it's important that you carefully read these questions, like in example 2 here. S of n is the nth term in a sequence. So this time S of n does not mean a sum, it means a term. But if it doesn't tell you anything like that in the question and it shows S of n, then it does mean a sum. But it can tell you explicitly to treat S of n as a term in a sequence instead of what it usually means. Now, enough preamble, let's get into it. G of n is the nth term in a sequence. G of n is equal to 3 times G of n minus 1 plus 2. What does that mean? A particular term in our list is given by 3 times the last term in our list plus 2. So this is why it's recursive. The way to get to the next term is to take the previous term directly and do some work with it. That is how we get from one term to the other. And we're also given the information that the first term in our list, G1, when n is 1, is going to be 2. So let's put this into practice now. We know G1 is equal to 2. What's G2 going to be equal to? It's going to be equal to 3 times G1, the last term in our list. So it's going to be equal to 3 times 2 plus 2 is equal to 6 plus 2 is equal to 8. This is our G2. What's G3 going to be equal to? It's going to be 3 times the last term, which is 8, plus 2, ends up being equal to 3/8 is 24, plus 2 is equal to 26. So that's my third term. My fourth term, the last one I'm asked for the next 3 terms in my list. The fourth term in my list is going to be 3 times, the last term is 26, plus 2 is equal to 78, plus 2 is equal to 80. So what are the first 4 terms in my list if I was asked for that? 2, 8, 26, and 80. So this is the difference in a recursive type relationship. Now again, we're going to look at our situation here where S of n means something different to what it usually means. It means a term in a sequence. So S of n is equal to 3 plus S of n minus 1, and we're told that the 0th term is equal to 5. So if I wanted to know S of 0, which we don't often deal with, though you can be asked to start a sequence at n is equal to 0 instead of n equals to 1. So we know that this is a difference between our functions type of work, our normal algebra, and patterns, is we tend to start at n is equal to 1 in patterns type questions, and we tend to start at x is equal to 0 for functions type questions, if we were sketching them. So in this case we are given n is equal to 0. So this is the first term, or the 0th term I should say, in our pattern, and now we're going to find the first term in our pattern. N is equal to 1th term in our pattern. So that's going to be 3 plus the last term was 5 is going to be 8. What's our second term? It's going to be 3 plus our last term is 8 is equal to 11. Whereas for the first 3 terms, S3 is the third term, which is going to be 3 plus the second term, going to be 14. So what have we got now? We have 8, 11, and 4 would be S of 1. Be S of 1, what we would usually call T1, T2, and T3. So we have A. Well, what do we recognize here? What type of pattern have we got? We have, we're told that it's going to be a linear or an arithmetic pattern because we're asked for S of n in the form a n plus b, and we recognize that that is a linear or an arithmetic pattern. So immediately we suspect we're going to get an equal common difference. And when we do that, we see that we are adding on 3 each time, which you can also see by just intuiting by looking at the type of pattern that we are dealing with. How do you get from one term to the other? You add 3 to it. But writing it out this way is good for making sure our thinking is very clear. So we have our common difference, and we have our first term is 8. So then our nth term is going to be a plus n minus 1 on d. Again, S of n is standing in here for what we would usually call T of n. So we have 8 plus n minus 1 on 3. So we end up with S of n is equal to 8 plus 3n minus 3. S of n is equal to 3n plus 5. So that is our recursive type relationships. And all we really need to be careful with is that they have a habit of using funny letters, particularly problematic that they can sometimes use S of n in a way that is contradictory to what we would usually think of S of n as being. But if we simply substitute in as we're asked to in these questions, even though they can look a little bit out of left field, they are not too bad. The maths doesn't tend to get very complicated with these questions. And that's what we need for now.